proportion refers to the relationship between variables, letters, ideas, concepts, where as one changes, the other changes. In direct proportion, if one thing goes up, then the other thing goes up. Or if one thing goes down, the other thing goes down. Think of a list of ingredients to make to go into a recipe. If the recipe is for, say, 2 people, it'll have a certain amount of ingredients. However, if you now need to serve 6 people, well, 6 is 3 times as many as was originally labelled, so you're going to need 3 times the ingredients. You increase the number of people it's serving, that increases the amount of food needed. In a direct proportion then, you may see this kind of symbol here, saying that y is proportional to x. So as x goes up, y goes up, x goes down, y goes down. To turn this into an equal sign though, because it's only when it's in an equal sign that we can start solving for anything, we'll say that y equals kx, where k is some constant that we need to find out. And we'll do that using numbers that the question gives us, and we'll get into an example of that in a second. Just to cover the other type of proportion though, that'll be inverse proportion. This is if one thing goes up, the other goes down, or if the first thing goes down, the other goes up. Take speed. If you're going to be traveling faster, if you increase your speed, then in theory, your time is going to go down. It's going to take you less time to get where you're going. In this case, say again this proportional symbol, but now y is proportional to 1 over x. Because here, if you make x larger, that means a larger denominator. A larger denominator means a smaller value for the fraction overall, so that will make y smaller. Whereas if you make x smaller, that's a smaller denominator, that's a bigger fractional value, y is bigger. But again, we need to turn it into an equal sign, so it's y equals k over x. Again, k being this constant we're going to find using details in the question itself. So for instance, if we had a question that said a is directly proportional to b, and when a equals 4, b equals 6. Or a is directly proportional to b, so it'll be a equals kb. This is not good enough in terms of constructing an equation. It's like if you have an equation of a straight line, your y equals mx plus c. The m and the c need to have values to give the gradient and the y-intercept, even if the y and the x then remaining generic. So if someone said to you, what's the equation of this line? You wouldn't just say it's y equals mx plus c. That's too vague. You need to say, what is m, what is c? Here, yes, technically, a equals kb, but it's not good enough. We need to know what k is. So we'll now plug in the numbers we have. So 4 equals k times 6. To get k on its own then, you just need to get the 6 away from it. If it's times on this side, it'll be dividing. So 4 over 6, which is the same as 2/3. Therefore, your equation is actually a equals 2/3 b. What if, however, it hadn't been directly proportional to b? It had been directly proportional to b squared, making that b squared here, and this 6 squared here. That would mean that when we divided the 6 squared over, that's actually going to be 4 over 36, which simplifies to 1 over 9. So this would actually be 1 over 9 b squared. In the questions, you always just want to be careful, are there any powers or any square roots or something? Especially also if they're not actually using these symbols in the question, they're instead using it in words. They may not say, have b squared, they may say the square of b, all written out. But either way, now that we have this, we're just going to stick with this version now, that a is 1/9 b squared. Now that we have this formula, we can just say, okay, we can find a new value of a. So what's a when b now equals 3? Well, if a is going to equal 1/9 times 3 squared, 3 squared is 9, 1/9 of 9 is 1. Going the other way round, what's b if a 7? Well, we can therefore say that 7 equals 1/9 b squared. We're trying to get b on its own, so we'll get rid of the 9th first. Deal with powers last. If you want any kind of recap on that, look at the rearranging formulas topic. But here, yep, if you want to get b on its own, we'll move the 9th over. Currently it's a 9th times b, so when it moves over it will become divide. So 7 divided by a 9th, well, that's going to be 63. So that equals, again, you put that in your calculator if you're not sure. That gives you b squared. Well, then how do we get b on its own? Well, how do you get with the square? You would square root. And you wouldn't have to work out exactly what that is, and that maybe the question specifies to 1 decimal place or something. But yeah, we can just leave that as that surd of root 63. If this is an example of direct proportion, then let's just do a similar example of inverse proportion. So in this case, we can now say that C is going to be inversely proportional to D. I'll say the square root of D in this case. So C is inversely proportional to the root of D. Now in this case, let's say when C equals 5, D equals 100. K over root D. In this case, we can then plug in our values. So 5 equals K over root of 100. Square root of 100 is going to be 10. So 5 is K over 10. To get K on its own, well, it's currently being divided by the 10. You want to move that away. If it's going over the equal sign, the sign will change. If it's divided by 10 on the right, it'll become times 10 on the left. So that will become 5 times 10. So K is 50. Therefore, we have that C equals 50 over root D. Now that we have this, we can plug in values that it gives us. So let's say that they then said, well, what happens when D is 25? Now that we have this, we can use it to work out, say, C if they give us a different D value. Let's say, well, what's C now, therefore, if D is 64? Well, then C will equal 50 over root 64. Root 64 is 8. So 50 divided by 8, that will get you a C value of 6.25. Alternatively, if they gave you the C first, I say, well, C is going to equal 91. Then if we want to make D the subject now, so 91 equals 50 over root D. To make D the subject, it has to get out of the denominator. You'll need to times it up here. So it'll be 91 root D equals 50. But then we'll divide the 91 underneath to get the root D on its own. And then just to get D in turn on its own, you'd then need to square everything. This, you once again are just going to put in your calculator. And if you do that, let's say we'll round to 1 decimal place. That's going to get a D value of 0.3. If we're all right with that, let's now just get rid of all of this and just give you an example, a practice question of. So let's say now that T is directly proportional to the square root of L. Now, L is increased by 40%. Work out the percentage increase. Now, this question is slightly different to what you have been doing already, because the question hasn't given you any numerical values for T or L. So what I'm going to suggest you do here is keep it in terms of T and L, just try to construct the equation as you usually would, and then consider just in terms of algebraic letters and their coefficients, what would L become if it's increased by 40%? And then, as you're trying to work out what T is becoming, maybe consider some rules from surds. Just a little hint. So yeah, pause the video, have a go for yourself, and then press play again when you're ready to compare. Alright, so to just construct the first equation, which we'll need before we start increasing anything, if t is directly proportional to the square root of L, then it'll be t equals k root L. Then from that, if we increase L by 40%, that's going to be 1.4 L. 1 because we're keeping the value we had before, and then 0.4 because, well, 0.40 is 40 as a decimal, and 40% is a decimal. Because of how surds work, because these are multiplied under here, you can then technically say that this is k root 1.4 root L, and then from there you can work out what root 1.4 is. It's approximately 1.18, so it's 1.18 k root L, so this must therefore be 1.18 t, because 1.18 times what the original value was. Therefore, what percentage has t gone up by is times by 1, because it's kept the same amount as before, and then the 0.18, that is 18% as a decimal. If we're okay with that, and we're happy with the difference between direct and inverse and so forth, let's have a look at then an actual paper. Is inversely proportional to d squared when d is 10 and y is 4. And then d is directly proportional to x squared when x is 2 and d is 24. Find a formula for y in terms of x. So we need to find a way of combining the y and the x. What they have in common is the d. So if we can get an expression for y in terms of d and then d in terms of x, we can substitute them into each other. So y is inversely proportional to d squared, where then, so y is going to be 4 equals k over 10 squared. Well, 10 squared is 100, so timesing that up, k is 400, so you have y equals 400 over d squared. Then here, if d is directly proportional to x, you can use k again if you want, but if you just want to make sure there's no confusion, as in they're not going to be the same number, maybe we use another letter, maybe let's say c, k and c, similar. So it's c lots of x squared. So 24 equals c times 2 squared. So that's 4. Here, to get the c on its own, you would be dividing by the 4 to get it on the other side. 24 divided by 4, that's going to be 6. So here we have d equals 6x squared. To just put these two into the same equation then, so you have y equals 400 over, now d squared is going to be the whole 6x squared squared. So expanding that bracket, you've got 400 over 36x to the 4. If you, because it says it wants it in its simplest form, if you just work out what 400 divided by 36 is going to be, that simplifies to 100 over 9, then yeah, that's still over the x to the 4. Y is 100 over 9x to the power of 4.